Assalamualaikum. So we are supposed to do the sixth problem of the binomial expression
It's the continuation of the last video, so I'm planning to do the sixth question, and this is the A part of that. We will try to do the sixth problem, because most of the people, finding some difficulty in doing the sixth problem, right? So we will slowly try and discuss the sixth problem now. 15a squared plus 2ab minus 8b squared was the first problem. So how are we going to factorize this, right? As we did earlier, as we were thinking earlier, what you should do is you have to find the, you have to multiply the coefficient of the first term and the last term. Look at this, 15 and 8. 15 into 8 is going to be how much? 100. How much? Quickly do your paperwork by pausing the video. So 15 into 8 is going to make simply 120. If you check, you can check it. It's going to make you 120. So you have to break this into 2 such that when you add them it should make 2ab, and when you multiply the coefficient it should make 120. Simple. So 15a squared is there, 15a squared, right, plus if you by what number you should break this in order to make 120. So simply it's 12 and 10. Look at this, 12ab minus 10ab minus 8b squared, right? 12 minus 10 is going to be 2a, right? 2ab, and 12 into 10 is going to make 120, right? Even though 8 is here, it's not 8, we have imagined that there is 120 there, right? And then we have to proceed with the sum, right? Cool. Now take this as a pair and take this as a pair. So what is common to both of them? 3 is common. Seems like 15 can be divided by 3 and 12 also can be divided by 3. Furthermore, a and a is common to both of them. Just take 3a outside the bracket, so you will get 3a, and inside the bracket you should get 5 is remaining and a is remaining. So 5a, and furthermore you are going to get 4a plus 4, sorry, not 4a, it should be 4b. Right? Now for this, 2 is common, right? Seems like 2 is common. Yes, 2 is common, and also b is common. So take 2b out of the bracket, and inside the bracket you are going to have 5a plus 4b, right? So 5a plus 4b is common for both of the equations. So take 5a plus 4b out of the bracket. So you are having 5a plus 4b minus into 3a minus 2b, and this is the end of the story of this first problem. Even though people find this difficult, it's a very easy question. Look at the second problem. They are asking to find a squared plus 1 over a squared. Given that a squared plus 1 over a squared is 47, they are asking to find a plus 1 over a, right? They are asking for the value of a plus 1 over a. So this is of course a very simple problem, even though people take it as a difficult problem. This is a very simple problem. This is the B part of the sixth question, right? So what you have is a squared plus 1 over a squared is given, right? Initially, think about this. A plus 1 over a whole thing squared is going to make you a squared plus 2 into first term into the second term, right? Plus the second term whole thing squared. This is what it's going to make, right? So once we have this, what are we going to have is a plus 1 over a whole thing squared is equal to a squared plus 1 over a squared. 1 over a whole thing squared is simply a squared plus 1 over a squared, because you have to multiply 1 with 1, so 1 squared, and below you have a squared, so 1 squared is simply 1, right? So you don't have to bother about it too much. And a here and a here is cancelled each other off, so plus 2 is there, right? They have given you a squared plus 1 over a squared. A squared plus 1 over a squared is 47, because they have given you, right? This is a problem, right? So this is going to be 47 plus 2. 47 plus 2 is going to be 49. A plus 1 over a plus 1 over a whole thing squared is equal to 49, right? Meaning this is also equal to 7 squared. Then what is a plus 1 over a? A plus 1 over a is simply 7, right? Another person can say even minus 7 is valid here. Yeah, that is valid here, but for UR level, you are not supposed to think about negative numbers too much, right? You don't have to bother about it too much, right? So a plus 1 over a is simply 7. Cool. So the next problem is you have to find 28 squared. 28 squared by factorizing 28 squared should be found by, sorry, not factorizing, by expanding, right? Sorry, I said factorizing, right? So it's a mistake from me. 20 plus 8 whole thing squared, you just have to expand this. 20 squared is, you have to put the first term squared plus 2 into first term into second term plus the second term whole thing squared. These are the problem works, right? So 20 squared is simply 400 plus 2 into 20 is 40. 40 into 8 is equal to 320. plus 8 squared is simply 64. Simply 64. Now add them. It's going to make you 4 here. 6 plus 2 is 8. So you're going to get 8 here. 4 plus 3 is 7. So the answer is 784 for the third part, right? Hope up until this point you may be a little bit of comfortable, but the last problem might have gone a little bit, little bit a mess or fuzzy for you people, right? But even though it was the case, even though it's the case, the last problem is very easy if you figure out how to do it, right? If you figure out how to do it, it would be the most easiest sum that you have ever faced in the quadratic equation. If you have recognized it better, right? You have recognized it completely. So the question is 39 whole thing squared plus 39 into 2, right? Plus 39 into 2 minus 99, right? So you have 39 squared, some term squared, right? Now instead of 39, let's put x, right? If we're supposed to put x, right, I think the problem will be much more easier than you thought, right? So 39, instead of 39 squared, we will put x. So you are going to get x squared plus, instead of 39, you are having what? X. So x into 2 is simply 2 into x, right? Because the multiplication, right, of numbers are simply commutative, right? So it's going to be 2x minus 99. Now you have to break this into 2 such that when you add them it should make 2x, and when you multiply the coefficient it should make 99. So what are the best numbers? You have to have a difference. Why should you have a difference? Because if you have a difference only, you are going to get, when you multiply the coefficient, it's going to make minus number, a negative number. If you have a sum, it will be the vice versa, right? So you have to have a difference. So x squared plus, instead of 2x we are going to have 11x minus 9x. Look at this, 11 minus 9 is 2, perfectly alright. 11 into 9 makes 99, right? It's not plus 99, still it's minus 9 because you have plus 11 and minus 9. Plus 11 into minus 9 is going to be minus 99 as we intended, right? Minus 99 is somewhere there. Now take it pairwise, right? So x is common for both of them, just take x out of the bracket, so you are having x into x plus 11 minus, take minus 9 out of the bracket, so you are having x plus 11 again, because 9 into 11 is 99, right? So this is the thing. X plus 11 is common, take x plus 11 out of the bracket, so you are having x plus 11 into x minus 9. Very simple, right? Now what? Instead of x, just substitute 39. Instead of x, just substitute 39, because it's 39 is just x. That's why we have substituted here, right? Instead of 39 we have substituted x. Now instead of x we are going to substitute 39, right? So that is the ultimate point. That is how we have to think these kinds of problems as well, right? So we are going to have 39 plus 11, and we are going to have 39 minus 9. So this is 50 into 30. You see how the sum turns to be very easy, right? Rather than 39 squared, 2 into 39, doing each and every step like that. Just simplifying this or factorizing this, it makes more sense, right? 5 into 3 is simply 15, so you have 2 zeros, so the answer should be 1500. Please don't forget to put the equal signs, right? Please don't forget to put the equal signs. This is how the nature of these sums, and this is how it works. You just have to simply substitute the values, and then you will have to move on with the sum.